Alright, what's up guys? In this video we're going to pick up with some calculus here. We're going to do some logarithmic differentiation. So I'm going to use logarithmic differentiation to find the derivative of the given function. So the function that we got here is f of x is equal to 1 plus 1 over x raised to the 4x. So logarithmic differentiation works well when you have a function that is quite difficult to differentiate on the surface. Sometimes using properties of logarithms will basically simplify the function down to a point where you can go ahead and differentiate it quite easily. So the first thing you want to do is begin by taking the natural logarithm of both sides. So we'll start off by taking the natural logarithm of this side, and then we take the natural logarithm of this side over here as well. Actually gonna need another set of parentheses, and then you just do it. So then you have ln of f of x. We don't do anything to that side, but this side we can use property of logarithms, which says the 4x comes down. Then you have ln of 1 plus 1 over x. And that's what you'll have when you apply property of logarithm on both sides. Then we can differentiate both sides with respect to x. So let's go ahead and do that next. So we'll differentiate this side with respect to x. So we got ln of f of x on this side, which we need to differentiate with respect to x. And then we also need to differentiate this side with respect to x as well. So ln of 1 plus 1 over x. Now we'll start with this left-hand side over here. Remember that the derivative with respect to x for ln of f of x, that's just going to give me f prime of x divided by f of x. Then on this side, I can pull out the 4 because the 4 is a constant. Then I'll have to apply the product rule. So this will be 4. It looks like I have 1 times ln of 1 plus 1 over x, because remember the product rule says that I'll have f prime times g plus f times g prime. So then this will be plus x times the derivative of ln of 1 plus 1 over x, which is negative 1 over x times x plus 1. And we basically have differentiated both sides. I used the product rule on the left hand side and I pulled out the 4. So you can go ahead and distribute the 4 back in if you want to. Now remember, the goal here is to differentiate this, so we're trying to find f prime of x. So clearly the only way to isolate f prime of x over here by itself is to multiply both sides by f of x. So that's what I'll do, but I'll go ahead and distribute in the 4 before I do that. So I'll have f prime of x over f of x, and again I'll multiply both sides by f of x in a second, but let's go ahead and distribute the 4. So if I distribute the 4, I'll have 4, and simplify on the inside here as well, I'll have 4 times ln of 1 plus 1 over x minus 4 over, am I right on that? Yeah, I am, because those x's will cancel. Plus 4 over x plus 1 is what you'll get when you simplify and distribute in the 4 on this side. Now let's multiply both sides by f of x, because we're trying to isolate the f prime of x over here by itself. So what's going to happen is the f of x is over here going to cancel out. So we're multiplying f of x times 4 ln of 1 plus 1 over x minus 4 times, or excuse me, 4 divided by x plus 1. So hopefully you see here that these cancel. So then you just got f prime of x. Now remember what f of x was at the beginning. Go back up here to the top. That was 1 plus 1 over x raised to the 4x. And then you just have to multiply by 4 ln of 1 plus 1 over x minus 4 over x plus 1. So technically that would be your derivative. Now you could go through and try to multiply the right hand side, but that is going to get quite nasty. So I would leave it alone and just leave it that way. So that's your derivative. So let me circle that for you. Actually, let me write out that that's in fact the final answer, so that you'll have that. So this is the final answer down here. Now this one, I guess maybe was a little bit more messy than the ones that I've done in the past on previous videos, but as you can see, there really wasn't a whole lot of work for this one. It just looked like it was. So I'll circle this, and that's how you do it. So if you have any questions about it, let me know. I'll be more than happy to talk to you about it. I'll see you guys next time.